Okay, so I'm going to make a quick video that's going to give you some more examples from sections 1, 2, and 1, 3, which was on solving equations. So 1, 2, and 1, 3. Because we didn't quite get to show some specific cases, some more examples. Alright, so we're going to start with section 1, 2, and we're going to work with solving an equation that contains fractions. So within an equation, there's a really powerful tool that you can use, and that is you can multiply both sides by anything you want. Now, in this case, we're going to multiply both sides by a number that's going to make the fractions completely disappear. Okay, so let me just tell you what page we're on. We're on page 15 of your book. So if you need to, pause, go get your book, open it up to page 15, and then hit play again. Okay, so we have, I'm going to write a little bigger, 2b divided by 5 plus 3b divided by 4 equals 3. So we have two fractions here. Now, I said we can multiply anything we want to both sides. Let's pick a number that would cancel out those fractions. For example, if I multiplied everything by 5, I can do that. As long as I multiply everything by the same number, I'm allowed to do that. Now, why would I want to do that? Well, let me show you. If I multiply this by 5 here, this 5 and this 5 would cancel, and I'd only be left with 2b. That's great. But that's not going to happen with the 4, right? 4 doesn't go into 5. Okay, well, let's think about a different number besides 5 that would cancel out the 4. But it would also cancel out the 5. Is there such a number that I could multiply everything by that number that would cancel out 5 and 4? There is. It's the LCD, or the lowest common denominator. So when you learned how to add and subtract fractions, you learned about the lowest common denominator. The LCD of 5 and 4 is 20. It's basically the smallest number that 5 will cancel into and 4 will also cancel into. So I'm going to multiply everything by 20, including the 3. Now where I have a fraction, I'm going to put them over 1 because it is on the top. Okay, so then here the 5 does cancel into the 20, and it leaves behind a 4 because it didn't, it's not just 5 and 5 like the last time. And that's okay. We can have extra stuff on the top. Our goal is just to get the denominators to go away. Okay, so now we have 4 times 2b, which is 8b. Bring down the plus. We're going to do that again. This time the 4 goes into the 20 5 times. So that leaves 1 there. I have 5 times 3b, which is 15b. I don't need to write the 1s underneath. On the other side here, I have 3 times 20, which is 60. I have to multiply this one even though it doesn't have a fraction because I have to keep my equation balanced. Okay, now I don't have any fractions anymore. This is great. So now you're going to go back to the steps that I gave you in class, right? First step is distribute. Don't need to distribute here. Second step is combine like terms on each side. I do need to do that. What I see here is I have 8b and 15b. They both have a b, so they're like terms. Combine them, that gives me 23b equals 60. Now I'm going to undo what's happening to the variable. This one is a one-step equation. There's only one thing happening to the b. It's being multiplied by 23. So to undo it, I need to divide both sides by 23. Cancel, cancel. All right, now that is a perfectly fine way of leaving your answer. Since 23 doesn't go into 60 and you can't reduce this fraction, you're done. Don't write it as a decimal. I mentioned in class that rounding things leads to bad answers. So just, you're done. There's your answer. Okay? If you have three numbers, like in part B, you need to think of the LCD of all three things. In this case, the LCD of 9, 6, and 3 would be 18. 9 goes into 18, 6 would go into 18, and the 3 would go into 18. So then you would multiply everything here by 18. I'm gonna write this a little bit. So I have 1/9 equals 5/6 minus m over 3. So I'm going to multiply everything times 18. 18. Okay, 9 goes into 18 twice. 6 goes into 18 3 times. 3 goes into 18 6 times. And then let's see what we have left. This is just 2 times 1, which is 2. Bring down the equal sign. 3 times 5, which is 15. Bring down the subtraction sign. Here I have 6 and an m. Okay, this is one of those weird ones that's backwards from what you might be used to. Remember, you can't switch things around if they're subtracting, but you can if they're adding. So let's change this to adding. Yes, we can do that. As long as we're adding a negative 6m. So then what you can do is you can take this 15 and this negative 6m, oops, something happened to my plus sign, there we go, and you can swap them so that you get 2 equals negative 6m plus 15. That's an optional step, but it's just going to help you feel a little bit more comfortable about undoing what's happening. Right, so now you can see you're going to subtract 15 from both sides. We get negative 13 equals negative 6m. Divide both sides by the negative 6. Now, we don't want to leave a negative divided by a negative. We always cancel when we have two negatives. But we can leave it as a fraction, so we can say that is our answer. Alright, I'm going to go ahead and we're now going to look at some examples from section 1.3. So this is on page 22 of your book. So if you need to, pause. Okay. So I'm just going to do a couple more equations when you have variables on both sides. So remember our steps. First, distribute. Second, combine like terms. Then third, this is the important one for these problems here, and that is to get variable onto same side. Okay, if we look at this problem here, we don't have any distribution to do. We're looking at number 1. We don't have any like terms to combine. Remember, when we're talking about combining like terms, we're talking about combining like terms on each side of the equal sign. Wow, that was messy. Clean that up. Right? So, negative 3c minus 12, those are not like terms. Negative 5 plus c, not like terms. So, don't need to do either of these, or I guess you could say they're done. Alright, now we're on the part where we're getting the variables onto the same side. So let's identify our variable terms. We have negative 3c and a positive c. It doesn't matter which way you go. You can move this one over there, you can move this one over there. I tend to like to do the one that's going to make the negatives go away. But remember, the key is you have to use opposite operations. So if it's negative, you need to add it. If it's positive, you need to subtract it. So let's say I'm going to move the negative 3c over here. I can't just put a negative 3c over here. When it switches the side of the equal sign, it changes sign. So it's a negative right now, so I'm going to add it, plus 3c. And whatever we do on the left, we got to do on the right. So the reason it gets moved is because these will cancel. A negative 3c and a positive 3c just cancel. Okay, so we're going to bring down the negative 12, the equal sign, the negative 5, and then we have c plus 3c. Remember this is like a 1c. So now we have 4c. Okay, so now we need to undo what's happening to c. So we have a negative 5 here. It's kind of like subtracting 5. So I'm going to add 5 to both sides. Negative 12 and positive 5 gives us negative 7. Bring down our equal sign, equals 4c. Then we divide by 4, and we're done. Again, we're getting lots of fractions here. Fractions are not wrong. Just remind yourself that, okay? Alright, let's look at the next page, page 23. And let's do more of like a word problem. We're going to look at number 4. A hairdresser is deciding where to open her studio. If the hairdresser chooses location A, she will pay $1,200 per month in rent and will charge $45 per haircut. If she chooses location B, she will pay $1,800 per month in rent and $60 per haircut. How many haircuts would she have to give in 1 month to make the same profit at either location? Okay, so let's start with location A. What is she going to have to pay? Well, she's going to pay $1,200 for rent per month plus 45. Well, actually, she's going to, let's think about this. $1,200 is rent, so that's what she's paying. So that's sort of like a negative amount. The $45 per haircut is what she's charging, so that's what she's getting, so that's like a positive amount. So I'm going to use H as a variable for the number of haircuts. Okay, so if she does 0 haircuts, then she's just going to have to pay $1,200. If she does 1 haircut, at least that is a positive amount that's going to help her pay this, right? So that's location A. Location B, she has $1,800 of rent, right? So that's negative because that's coming out of her pocket. But she gets to charge, she's going to charge more per haircut. So $60 per haircut. So we want to know, when is she going to have the same profit? This is basically her profit. Each of these are the profit at each equation. So if we set them equal to each other, so 1,200 plus 45H equal to, negative 1,200, negative 1,800 plus 60H. If we solve for H, that is going to give us the number of haircuts that she needs to make the same amount at each location. Okay, so we got variables on both sides. We don't have distribution. We can't combine any like terms. So let's get our variables onto the same side. So I'm going to move the 45H over. You could move the 60H over. It doesn't matter. I always like to move the smaller one. This is positive, so I'm going to subtract it. Okay, point of subtracting is so that those cancel. Bring this down, we get negative 1,200. Bring this down, equals negative 1,800. 60 minus 45 is 15H. Okay, now I'm going to undo what's happening to h. So I'm going to add 1800 to both sides. That's 600 equals 15h. Now I'm going to divide both sides by 15. Let's get a calculator. 600 divided by 15 is 40. So h is 40. So if she does 40 haircuts, she'll make the same amount at both. Okay, let's do one more problem that kind of combines. Let's do number 5 on at the bottom of page 23. So let's recall our steps. First, distribute. Can I distribute anything in this problem? Yeah, I can. Specifically, if I look, I have some parentheses, and in front of those parentheses, I have a negative. Remember, that's like a -1. So we have to distribute a -1 here. So I'm going to have 2r. -1 times 5 is -5. -1 times a -r is a positive r. When you're distributing a negative, essentially what you're doing is just changing the sign of everything inside the parentheses. Okay, nothing to do on the left or the right. I'm just going to copy it. Okay, step 2. Combine like terms on each side. Okay, you can't combine across the equal sign, so here are the sides. Can we combine anything on the left? We have 2r, a -5, and an r. Yes, we can. We have r's. So 2r plus 1r is 3r minus 5. Can we combine anything on the right side? No. Now, I just switched these, the 2r and the 13. You're allowed to, but you don't have to. Okay, step 3, get variables onto same side. So I'm going to subtract 2r. Like I said, I always pick the smaller one to move, but you don't have to. The 2r here is positive, so I'm subtracting it. Okay, whenever you move something from one side to the other, make sure you're lining things up with like terms, right? I wouldn't put the minus 2r under here. That doesn't make any sense because I can't combine that with 5. Okay, so, but I can combine it with the 3r. So 3r minus 2r gives me 1r, or just r. Bring down the minus 5, bring down the equals. These canceled, equals 13. We're almost done. There's only one thing happening to r. We're subtracting 5 from it. So to do the opposite, we're going to add 5. And our answer is r equals 18. Okay, I hope these examples helps you out with 1, 2, and 1, 3. You can email me if you have any other further questions.